Welcome to our channel. So in today's lecture, I'm going to explain about atomic. I will write in here as well. So I'm going to explain atomic absorption spectroscopy. Spectroscopy. So this is one of the key analytical techniques that is used to detect metals in any compounds, particularly if you are in the quality control, based in the quality control lab. So you use atomic absorption spectroscopy to detect metals like sodium, potassium. So these are the most common metals that are detected. So currently I'm working with one of the metals, one of the compounds named as macrogol or strigol. It's a powdered for the oral solution that comes in 13.72 gram powder for oral solution. So in this macrogol powder, we are detecting different kind of metals, like we are detecting sodium, one of the key. Then we are also detecting potassium. Then we are checking the concentration of chloride and also as well as bicarbonates. Bicarbonates. So its whole test, microbole analysis, is based on the detection of these metals. So what we actually detect in these metals using absorption spectroscopy. So if I'm going to discuss, like, if we are doing atomic absorption spectroscopy, so for sodium and potassium, we are doing two tests. One is SA and the other one is CU. We also called it as content uniformity. Content uniformity. So in SA is like we take 20 sachet of microbole, but in this case, generally for the SA, we're taking 20 tablets and then making a solution. But for this microbole, we are taking not 20, we are taking like 10 sachet. In each sachet is around 13.72 gram. So we are taking 10 sachet into 500 ml flask, and further it involves some dilutions. And the final dilution, if we are doing for the sodium or for doing the potassium, the final dilution will be with cesium chloride, CsCl. Why cesium chloride is used, we will discuss. Cesium chloride, basically, if you go into the metal periodic table, so it goes like hydrogen, sodium, potassium, rubidium, and cesium. So we are detecting sodium and potassium. So these are very strong ionic compound that make a strong bond with the halogen counterpart halogens. So sodium chloride, potassium chloride, and here it comes the cesium chloride. So when we are using cesium chloride, it acts as a ion suppressor. What does it mean by ion suppressor? Basically, in atomic absorption spectroscopy, we need to detect the metals in its atomic form. So if we are detecting it in an atomic form, it should not ionize. So why it shouldn't ionize? Like cesium can ionize readily. So there are a lot of cesium ions in the, like, see, it's a positive ions, lot of positive ions already in that matrix. So it's very difficult for sodium to get ionized into plus form and lose electron because it's already saturated with cesium. So it's very difficult for sodium and potassium to change into the ionized form. That's why they remain in the atomic form and can be detected using atomic absorption spectroscopy. So this is one of the key concepts of using final dilution with cesium chloride. And then the second term is the content uniformity. In content uniformity, we are detecting the content, individual content of the sodium or potassium in each sachet. Like if you are for CU, generally we are taking 10 sachet and we are taking individual, like one sachet we are dissolving it in 50 ml of water, and then it follows further dilution. And again in this one, the final dilution will be with cesium chloride. So in this way, atomic absorption spectroscopy help us to detect the concentration of sodium and potassium in like collective 10 sachet as well as in individual sachet as well. So how atomic absorption spectroscopy help us detect, that we're going to cover in the next lecture. Thank you so much for watching.